going to work when I start to record. Everyone's on spring break this week, except me. All right, so example number 4, you're given 2 triangles, and then you were told that they're similar. So if you remember when we started talking about the idea similar, that's this little weird squiggly sign. So the triangle on the left is similar to the triangle on the right. That means their angles are congruent, and then their sides are at an equal ratio through each corresponding side. Letter A, all we want you to do is find the scale factor of WXYZ to triangle DFG. So the scale factor is the ratio that compares the lengths of one triangle to the other. So since this is listed first, and we want to find the ratio of WXYZ to triangle DFG, even over here, this is first and this is second. So we're going to write our ratio in this fashion, from the smaller triangle to the bigger triangle, all right, when we set this up. So in order to do that, if we kind of compare these sides, what we want to understand about this, let's find some corresponding sides real quick. So WZ corresponds to DG. Well, if we try to set up a ratio for that, a scale factor, which is just our ratio, if we try to set that up with those, we don't know either one of those lengths. So that wouldn't do us any good to use those corresponding sides. If we go to another set of corresponding sides, so if I use this side here and its corresponding side here, notice how we know the 3, but we don't know the length of G to F. So we wouldn't be able to set up our ratio with that one. So the one that we would want to ultimately use is if we come down here to the bottom length on the small one and then the bottom length on the big one, notice how we know both of those values. So that's the set of sides that we're going to use to set up our ratio or our scale factor. So what we would then set up, since this is first, this is second, we would list this. There's a few different routes we could take. Right now it's 4/6. It's 4/6. We can reduce that down to be 2/3. If you write it as a fraction, that's fine. You could certainly see this written as a ratio using the little colon, or we can just verbally say that it's 2/3. So for every, if you think of it in terms of money, for every $2 that I have, Mr. Kubowitz would have $3. All right, that's how we can kind of compare those. All right. So that's our scale factor. All right, letter B. It should start out nicely here. If I want you to find a measure of angle Z, do that one real quick. There's nothing new with this. So find the measure of angle Z. This is an old idea that all of us knew quite well last module. So write that in and do the math there. I gotta change out anyway. All right, and Ahmed, I saw you first, Ahmed. What do you think for angle Z there, bud? Did he? All right, go ahead then. Oh yeah, go ahead then. Get the question then. Yeah, I mean, we can double it with 1 to 2. That's a fraction also. That's the same as saying 1 to 2. These are a little bit nicer. It's a little easier to kind of comprehend. A 1 to 2 is getting doubled. But it's the same process here, like 2 to 3 and 1 to 2. That's how we would write it with a ratio. But that's 1/2, 2/3. It doesn't matter. Like if you want to give the fraction, that's totally fine. If you want to write it as this little ratio here or say it in words, those are also fine. When we start finding values in a minute, so when we come down here to do the GF, then I would strongly recommend you're going to want to deal with the fraction, because we're going to have to set up a proportion to do that. And a proportion is 2 fractions set equal to each other. So we're going to want this fraction version. You could really use the unreduced version as well. But to just answer letter A, I don't care which of those 3 versions you write. Yep. All right, so Ahmed, give me angle Z then. What would angle Z have to be up here? All right, and how'd you come up with that? What was your thought process? Good. 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 So then we took 127, subtracted it from the total amount of 180. All right, and you got what, Ahmed? Good. And then that should be a 53-degree angle. So angle Z is 53 degrees. So old idea, nothing crazy there. Now we get into our proportions. This one I want to make sure we can set up. So look at what we have set up here. We have DG. So if you look at the big triangle over here, DG is this blue region. So we took that and we compared it to WZ and the small one. So we went the big triangle to the small triangle. So sometimes, especially as you're just learning this, I'm going to write these. Sometimes you can write what we just did. We did the big triangle on top and we did the small triangle on the bottom. So when we come over here to the one that we now have to define ourselves, you better make sure the big triangle's length is on top and then the smaller triangle's length is on the bottom. It has to maintain that ratio. So when we then look at WX, WX is the one that I did in the powder blue here that I stumped. This is Cam, right? Isn't it North Carolina? Yeah, I'm kind of liking the powder blue I stumbled on yesterday. I kind of like that color there. Yeah, so if WX is the bottom, that's the bottom of the small triangle, then the bottom of the big triangle has to be the numerator. So that would be that D to F. All right. The reason we have to now be able to set these guys up. All right, thanks, Gavin. The reason we have to be able to set these up that we just did over here is so now I want to figure out what is the actual length of GF. So actually that's the one that I have this big question mark with right now. All right, we want to now figure out what is that length. That is why finding the scale factor is now important. So what we would want to do is set up a proportion. So set up a proportion, which is just two equal fractions. One fraction needs to be when we have a complete set of corresponding sides. So these powder blue ones, the bottom, don't we know this entirely? That's how we set up our scale factor to get 4/6. So I'm going to set this up as the 4/6. You could also use the reduced amount. So we could do the scale factor itself and do 2/3. All right, doesn't matter. Understand what we just did with that now? The 4 is the small one on top, and then we put the bigger triangle's length on the bottom. So when we come over here, better be the exact same thing. We want the small triangle's length on top. We want the big triangle's length on the bottom. So if we look, the small triangle, if we want GF, GF is the big length on the big triangle. So we're going to put GF down here because that's the length that we're looking for, and that's on the bigger side of the big triangle. And then its corresponding side in yellow in the small triangle should have been 3. All right, can we understand how we set that up? Yeah, Kim? It is, and that's what I just, if you see here, I turned my eraser on because the next thing I'm going to do is I'm going to get rid of the GF, if my eraser will work. It's kind of working. And that's what we're solving for, right? So that's ultimately going to be, yeah, there we go. That's going to be the variable that we now assign to that position so that we can just solve this proportion real quick. All right, so then we can solve these pretty good. I've looked at a few of the homeworks this morning. Crisscross, multiply, the 4x is equal to 18. And then divide by 4, and we get 9.5, or 9/2. All right, so that's the measure of that length. Yeah, Ahmed? It's possible. What was your way? There's certainly some different routes you could take. Did you get 9/2? Good. All right, say that one more time now. That actually did lose. Hold on, let me create some space to write it. All right, go again. Okay, so he took the yellow side and he compared that to the blue side, and then he went over here. As long as he does the yellow side of x and divide it by the blue side of 6, you're going to get the exact same thing. Okay, so all kinds of different. So the one question that we did, remember how we compared, determine if we flip everything around, are they still equivalent to each other? That's just to show that there's a lot of different ways that we can set these up. Yeah, so good. All right, hopefully we understand kind of what he just did here. He did 3 to 4, yellow to blue. So as long as he does yellow to blue in the other fraction, that should also work. All right, good. All right, E. Find the measure of angle G. These should actually do E and F. These should be pretty easy. So find the measure of angle G and the measure of angle F. Or sorry, F is the measure of D. So G and D. See what we get for those. All right, Cam, what would G have to be? Good, because that has to be congruent to what angle? Good. We can either look at the graph to determine that G and Z are corresponding, or we can look at our congruency statement and see that the G and Z are the third letter listed, so they have to have the same degree measure. All right, and then pretty much same idea with the D, right? Like if we understand that D corresponds to W, that's got to be 37 degrees. Or look at your congruency statement, the D and the W are first listed, they have to have the same degree measure, okay? All right, G real quick. See what you think for G. It's one of these proportions. So look at how these got set up and tell me what that denominator would then have to be. Let me create a little space here. All of this. Let's see, WZ. Good. This one is kind of like how Ahmed did his. He used the one triangle on the left and then devoted the entire right-hand triangle to the ratio on the right. All right, what do you think, Kim? Good. Good. G to F. We went WZ to ZX. So we did the blue side to the yellow side in the small triangle. So as long as we do the blue side to the yellow side in the bigger triangle, then we should be good. And the yellow side was this GF. All right, good. All right, so those are those notes. I do want to do this first question together if it'll move for me. There we go. Different looking shape, but there is something in here too that we want to talk about. So this is your homework. You're going to do these next 2 pages. I think there were 7 total problems, at least numbers. There's some different elements to them. Yeah, so 1 through 7. So go to number 1, and now you're given a polygon. So these are quadrilaterals, and actually we could say that they're trapezoids because we know the top and the bottom line are parallel to each other. Find the scale factor of HJKL, so that's the triangle on top, to the polygon WXYZ, the polygon on the bottom. So if we want the scale factor, what we then again have to notice, here is HJ. HJ corresponds to WX. That doesn't do us any good because we know one of them, we don't know the other. We have to find the set of corresponding sides that we know both lengths of. So when we look at that, identify what 2 sides or what side on each of those correspond, and we know those values. All right, what are they, Kim? Good. HL and WZ. We know this is 4, this is 2.5. It's the only set of corresponding sides that we know. So those are the ones that we're going to use. We're going to go from the bigger one to the smaller one, since that's what's listed first. That's also what I gave you here, first or smaller, or to the bigger to the smaller. So when we set this up, your scale factor, we're going to write this as 4 compared to 2.5. And again, you can put the word to, you can use the colon, but at some point we need the fraction anyway. All right, so here's why I want to do these. So I'm going to give you a minute to see if you could set this up on your own. Find the length of WX. See if we now could set that up and figure out what this would be. Because it just so happens to be this blue side that I have shaded. I'd like you to, try to set something up because I did it one way earlier and Ahmed did it a different way, and we both got the same answer. So there's a number of different setups that will give you the same answer. As a check, so Cam's ready to give me an answer, I think. Understand if this answer is reasonable. Notice how the 4 went down to a 2.5, so it's a little bit smaller. So the 16 better get a little bit smaller as well. All right, so if it's a number smaller than 16, there's a reasonable chance that we are correct. It's at least a reasonable answer. All right, I honestly don't know what the answer is, Cam. What'd you get? 10 seems reasonable. So let's give me the setup, and then we'll see if this is good. So how did you set this up? What was your proportion? Good. So he took the big yellow side, that's the 4, compared it to the small yellow side of 2.5. So since he went big to small, then he's going to do the big blue side of 16 to the big small side of WX. That should be good. So when we now crisscross that, solve that, 10 then should end up being our answer. All right, good. All right, let's label this. So this is 10. Recall what the tick marks mean, right? Because now what I want you to do is find the perimeter. Actually, do this. See if we can do this. Since we've got plenty of time to burn, we're just working on your homework anyway. Tell me the perimeter of W, X, Y, Z. So this small side down here, go ahead and do that. Don't overthink it. This should be easy. All right, Ahmed, what do we get? Good. Should get 27.5. How'd you get that? Good. Is it? Good. So we add up all of these sides. We had 2.5, we had 10, we had 5, but we didn't know this side, right? But what he said is he knew that these had tick marks. So from last module, tick marks mean those sides are congruent. Now that we know that side is a 10, this side must also be a 10. Add all those up. When we add all those up, should give us this 27.5. All right, good. All right. Another one that I want to see if we can do here. The reason we're doing these together. Find JK. So JK, let me do a different color here. Do this in lavender. Find that length. Now we have many, many different options to get this set up. All right, think you got it, Cam? Good. So let me highlight the corresponding side. So we're looking for JK. its corresponding side in the small one is here. So give me that one more time. You set up what? All right, so he did the blue side in this rectangle, or in this polygon, to the purple side. So he did blue over purple. He stayed with the small one. So when we go to the big one, he then did the big blue side over the big purple side. That should be good. All right, that should be the correct setup. All right, crisscross. So we get 10x equals 80. What'd you end up getting, Cam? Good. And then we should get the x value to be an 8. So we now know that jk is 8. Find the perimeter of hjk. So same thing we would have done before. Ahmed told us these tick marks, or just reminded us, it means these are congruent. So this has to be 16. So do 16, 4, 16, and 8. Add all of those up. What's that, 20, 36? What was that, 44? So this has a perimeter of 44. Should have left you a little more room to operate in there. It's getting a little tight. All right, so that's our perimeter. All right, now it asks you, find the ratio of the perimeter of these. So the perimeter of the smaller one was 27.5. The perimeter of the bigger one, we just found to be 44. So now find the ratio of those. What I'm going to have you do, when we did the scale factor up here, notice how we did the bigger side compared to the smaller side. Do that with the perimeters as well, just so we can see what I want you to see here. So if I did the perimeter of the big side, that's 44, compared to the smaller perimeter of 27.5. That's the ratio of our perimeters. Oops, come on. Oh my gosh. Doesn't want to erase here. So let me try this one more time. So right now, if we look at the ratio of the scale factor at the beginning and the ratio of our perimeters, those don't necessarily look the same, correct? But if you throw these into your calculator, if you do 4 divided by 2.5, if we reduce that down all the way by division, should give you 1.6, correct? Do the same exact thing with the ratio of our perimeter. So now do 44 divided by 27.5. That should also give us 1.6, correct? So that is something we want to make a note of. That's something we want to know for future reference. Whatever the original scale factor is, that would also be the scale factor of our perimeters. All right. So in the future, we wouldn't even have to have done that work. We could have just done 1.6 and said that that's our scale factor for this as well. All right. All right. Last one, angle W. So we're looking for this angle right here. If you notice in this one down here, I don't give you any of these angles. But we do know that these are similar. So because they are similar, corresponding angles, so angle J corresponds to angle X. So we know angle X must also be a 62-degree angle. However, that's not the angle that we are looking for, right? We're looking for angle W. So this goes way back. What we're looking at is, remember how the little arrows mean we're parallel? So here is our parallel line, and this is a parallel line to that one. And then remember the little thing we call the transversal. Here is a transversal right here. Do we see how this purple angle is a same side interior angle from all of that stuff from last module? Same side interior angles are supplementary. So if I know this is 62, then I know that this has to be 180 minus 62, which is 118 degrees. So this has to be a 118 degree angle. All right. All right, last one I want you to do, and then I'll let you go for the day. Get out a little early. I want to do one more proportion. Go to number, let's see here. Go to number 3. See if you can find X. So we'll do X and then call it a day. So if you look at number 3, you're given 2 triangles. I want you to find the value of X. So do something to figure out what X is. My word is just about ready to crash. This might be a good place to end. Oh, here we go. There we go. Oh my God. All right, hopefully we have it by now. I don't know what this is doing. All right. What I want to see if we understand then, because this doesn't just come out and say it. The only way that you can get this is by setting up one of those proportions. So we just have to recognize if we're going to be looking for these, you got to set up a proportion with our 2 similar triangles in here. So what we would want to see, we have to figure out which set of corresponding sides we know both values of in the big triangle and the little triangle. So that has to take us to this side and this side. Those are the corresponding set that we know both lengths of. So one of your proportions has to use the 4 and the 6. I am going to go 4 to 6. I'm going to go from the small value to the large value. If I want X, maybe I shouldn't have changed this. Thing's about ready to crash. Here's X. Its corresponding side is right here, the A to the B. We have to go small to large. So the 6 has to go on top. The small side is the big side is the X value. That has to be our proportion that you were then setting up. All right. And then once you set it up, it's easy. Looking at the homeworks last night a little bit, we understand this pretty nicely. Crisscross, multiply, divide by 4, and then we know that this X is a 9. All right. But then that's what you're going to do for Y. That's what you're going to do for the rest of those problems down there. All right, you've got to be able to set up those proportions and then be able to solve them. Okay. All right. So with that, that is your homework. You're going to do 1 through 7. We've already got a bunch of those done. All right. If there's any questions, we got a little time tomorrow. We can talk about them real quick. Just make sure that those get uploaded onto Canvas before tomorrow night at midnight. All right. All right. With that, you can have a few extra minutes there. We'll see you guys tomorrow. Have a good day. All right. Take care. Stop recording.